Welcome to Algebra 2. This is homework week 2, I think. So let's start. Question 1 is asking you to find the correct recursive definition. Um, a recursive definition basically is the way that we think. If you look at this right here, how would you describe this sequence? You would say it's timesing by 2. Well, to be very specific, you have to take the previous term times 2 to get the new term, right? So that's what recursive definition is. Um, when you define the new term by taking the previous term and either adding or multiplying um, a constant, that's how you define recursive definition. If I were to write it, let's just say, I'm just going to give an example of how to write it. In order for you to write a recursive definition, it requires three identifiers kind of thing. So we need to make sure that the sequence is unique, that the definition of the recursive is unique to one sequence. How do we do that? There are also two things that actually makes a sequence unique. What if you simply say that this specific sequence is timesing by 2? That is not enough. There are infinite sequences in this world that that has times 2. Another example would be 1, 2, 4, 8, and so on. This sequence is also timesing by 2. Then how do I explain to someone, or how do I write it in such a way that the definition that I'm about to write is unique to this specific sequence? In order to do that, we just write the first term itself. So let's say we are defining this sequence as ace of 1 of 3. The first term is 3, right? That's basically what we are saying. Ace of 1 is 3. Now, what is then you would say, hey, since I know the first term, how would you get the second term? All you say that take any new term, ace of n is any term, take the previous version of that. So like, for example, let's say you're trying to find the second one. What you will do is take the first one, and in this case, you will do times 2. This right here is extremely like unique kind of thing where this is specifically for this one itself. We cannot create any other sequence. This right here together creates only this sequence right here. We also say n is greater than or equal to 2 and integer. Why do we do that? Here's why. You see, you already defined the first term, so you don't have to plug in 1 again. You already know what the first term is. You need to, for n, you need to plug in 2, 3, 4, and 5. That's what this is saying. That hey, I'm already telling you what the first term is. I'm defining it for you. For you to find the next term, which is the second term, you have to plug it in. That's what this is saying. Second term, third term, fourth term, you have to plug it in. Okay, so this matches with this one. So this is your answer. Like I would match it like that or something kind of thing. Same thing for part B. Now, how is that changing? I can see it's dividing by 3, timesing by 1/3. They said dividing by 3, but if you were to write it, you would not say dividing by 3. You would say timesing by 1/3. So this matches with that. And I will give an example on how to write that. So again, very first thing, define your first term. Let's call this sequence B. So b sub 1 equals 81. The first term is 81. After that, b sub n equals b sub n minus 1 times 1/3. Because it's dividing by 3, right? Kind of thing like timesing by 1/3. And then you would write the same thing again. N is greater than or equal to 2, and it's an integer. Now, same things. I'm not gonna write this version of this one. You can do that on your own. The only thing that would change is that this is a fifth, this is 5, and then this is plus 5, right? So this is that number, yeah, plus 5. Alrighty. Let's look at question number 2. You're asked to again find the recursive definition. We need to figure out A, what kind of sequence this is. So looking at it, I can see that it is decreasing drastically. So it's not an arithmetic sequence, it's geometric sequence. And I can also see the first term of the sequence. Again, the x value is a term number, right? Which is the first. So your first term is 16, right? As you can see, the first term is 16. The second term is 8. The third term is 4, and so on. This information is more than enough for me to figure out what the pattern is, and I think it's more enough for you as well. If you want to pause the video and try to figure out what the recursive definition is, you can, and I'm going to tell you the answer now. It's timesing by 1/2. So very first step, define the first term. Ace of 1 equals 16. This locks in, right? When you define your first term is 16, it locks into all the sequences that starts with 16. Now, you're going to say ace of n equals ace of n minus 1 times and a half, because it's timesing by a half, right? You might wonder, is this always the case for us? Yes, this is always going to be the case for you. In simple English, you aren't you always going to say that the new term is taking the previous term and doing something with it? This is symbolic version of that. The new term is taking the previous term and doing something with it. This is always going to be the case. Because in English, you always say that the new term is taking the previous term. That does not change. Here, n is greater than or equal to 2, and integer, you can say that as well. You should say that. It's these three things together completes your answer. Alrighty. I cannot see, but the first term seems to be 1. Second term seems to be -2. Third term seems to be 4. Fourth term seems to be -8, and so on. So again, you'll define your first term, which is 1. Ace of n equals ace of n minus 1. The new term is taking the previous term and doing what? For this one, it times in -2, right? And then you do copy the same thing. You will copy this same thing here, and your answer is done, right? I'm going to create the sequence for this one, but I'm going to leave it as it is. I want you to figure out what the recursive definition is, but I'm going to write down the sequence for you. This comes to be as 1.5. This is 3, 4.5, and so on. Write your recursive definition exactly this way, not a bit different, but like the process should be the same, right? Cool. Let's move to the next one. Cool. Now you're given a recursive definition and you have to tell me what the first 5 terms are. It's quite simple actually. Well, this is actually pretty interesting, I would say, because so far we have been doing the opposite thing. Given a sequence, you tell me the recursive definition. For this one, you're given a definition, you're telling me the sequence. I think it's kind of interesting where now I can actually show you how your thinking process works. Let's start reading, okay? Ace of 1 equals 10. Just by knowing that I know my first term, which is 10. After that, you can say each new term is taking the previous term and adding 3. Each new term is taking the previous term and adding 3. 10 plus 3 is 13. 13 plus 3 is 16, and so on. I'm asking you to find the 5 terms, so I'm going to do that. 19 and 22, and then so on. That's 5 terms, right? Yep, that's 5 terms. I can see that. Yep, 1, 2, 3, 5. Yep, 5 terms. Alrighty, moving to the next one. First term is 2 times in 3, 18 times 3. Ooh, you cannot see. So, first term is 2 times 3 gets 6 times 3, which is 18. 18 times 3 is 54. 54 times 3, I'm not going to do that. You guys can do that. Figure it out. Cool. This one actually kind of amazing. They're giving you 2 terms. The first one is 1. Second term is 2. Now they're saying that each new term is taking the previous one and the one before that and then adding them. And hence, look, they're also saying it n is greater than or equal to 3 because they're already giving the first 2 terms. So it's kind of amazing to see the logic working everywhere. Basically, they're saying take To make any new term after the second term, take the second term and then take the first term and add them together. You get 3. 2 plus 3 is 5, 5 plus 3 is 8, and so on. And you're done. That's it. This is you're done. For this one, you're done for sure. Let's do it. Question number 4. Consider the sequence defined by the rule a sub n equals 3n. Which of the following values could be used as inputs for n, and explain why? Whenever we talk about n, what do we say? We say n has to be greater than 1 or something like that, right? Greater than or equal to 1, an integer, right? That's what we've been saying there, right? N has to be greater than 1 or equal to 1 and an integer. So D cannot be an answer, C cannot be an answer, D cannot be an answer, so A is your answer. You cannot have negative 1th term, you cannot have 3.5th term, you cannot have 0th term. Sometimes you might have that, but they will define you that. But the majority of them, they won't have that. Which of the following could be a possible value for a sub n? Explain why. It could be any of this. A, B, C, and D. Any of these could be. Let me give you an example of each one, okay? 6, 7, 8, 9, and so on. Is this a sequence? It is a sequence, arithmetic sequence, increasing by 1. A and B is done, right? Now, for this specific one, they're asking you a sub n is 3n, right? Which one will not be the answer? Well, if you're saying it's 1, 2, 3, or 5, B cannot be your answer, C cannot be your answer, D cannot be your answer, so A's answer is 6. But what if you're not given the sequence? 3 sub n. And what if you're not defined a sequence? Any of this could be your answer. Any of this could be a possible value. But because you're locked into 3n, only 6 can be your answer, because look, 3n, you're going to have 3, 6, 9, 12, right? Yeah, yep, and so on. So 7, you don't have it. Negative 3 is not possible. 0.4 is definitely not possible. So only possible answer is 6. Cool. Moving on to the next one. I cannot see. Okay. Second. Here's a rule to make a list of numbers. Each number is twice the square of the previous number minus 1. Okay. Starting with number 2. Let's say you're starting with 2. They're saying each number is twice the square so of the previous number. So twice the square meaning, oh, it's saying each number is twice the square of the previous number. How would we do this? Well, okay, starting with this, what is the first thing that's happening to the previous number? Well, it's squaring and then you're multiplying by 2. So basically you're saying it's 2x minus 1, where x is like the previous term itself. 2x squared minus 1, that's what I meant, 2x squared minus 1. So let's do that. Plug in 2 for x, you get 2 squared, which is 4. 4 times 2 is 8. 8 minus 1, which is 7. 7 squared is 49. 49 times 2 is 98. 98 minus 1 is 97. Yep. And then 97 squared, you can do that. Times 2 minus 1, whatever that is, and so on, right? You guys can figure it out. Okay. 6. Each number is 5 more than twice the previous number. Basically, it's the previous number, let's say it's 4. What is the equation? The equation is twice the previous number, so it's 2x plus 5. So 4 times 2 is 8. 8 plus 5 is 13. 13 times 2 is 26 plus 5 is 31. 31 times 2 is 62 plus 5 is 67. 67 times 2, 134, I think, plus 5 is 139. So I'm assuming it's 134, but you can figure it out, right? Plus 5 is 139. But yeah, make sure the math is right, okay? This is right, the equation is right. Okay. Moving on, a sequence is defined by this. Let's create the sequence first, right? So we're gonna say, so see, they define it as 0th term is 7. They will do that sometimes just to throw you off. Don't worry about that, just doesn't matter, okay? 7 minus 2.5. Oh my god, 4.5 minus 2.5 is 2. Minus 2.5 is negative 0.5, and so on. To write an nth term of the sequence, also known as the explicit formula. We use the formula a sub n equals a sub 1 plus n minus 1 times d. A sub 1 in our case is 7. It's even though they've defined as 0, but this is your first term, which is 7 plus n minus 1. We'll leave as it is. We'll leave n as it is. Your d is a difference, which is negative 2.5. Subtracting 2.5, right? So yep, you get 7 plus 2.5 minus 2.5 n. So this is 9.5 minus 2.5 n. This is your answer. But because they're asking for n, you can just say it here where n is greater than or equal to 1. Because if you plug in 1, you get 9.5 minus 2.5, which is 7, you know? Okay, let's move on to the next one. Create an arithmetic and geometric sequence, write it in recursive form and explicit form, and oh my god, graph it. Okay. Alrighty, I'm sorry, I'm making you do this stuff, but let's do it. Okay, starting with arithmetic, go simple. Well, 1, 3, 5, 7, dot, 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 that's arithmetic, right? Definition, recursive definition is the first term, which is 1. The next term is taking the previous term and adding 2. And then, where n is greater than or equal to 2. An integer, right? And integer. We use the formula for that's explicit. This is now we do sorry, this is recursive. Now we'll do explicit. The formula for that is again a sub n equals a sub 1 plus n minus 1 times d. First term, which is what? 1 plus n minus 1, which is, leave it as it is. Your difference is 2, right? Because you're adding 2. You get 1 plus 2n minus 2, which is 2n minus 1. You can check your answer, plug it in. Plug in 1, you'll get 1, which is your first term. Plug in 2, you get 4 minus 1, which is 3, which is the second term. Plug in 3, you get 6 minus 1, which is 5, your third term, and so on. This is the explicit form, 2n minus 1. And now, let's graph it. You get 1, 2, 3, 4, 5. 1, 3, 5, 7, and it's like a linear growth, right? It's a line. It's like 1 comma 1, 2 comma 3, 3 comma 5, 4 comma 7. Cool. Moving on, we'll do geometric now. Let's say 1. I'm gonna go a little bit tougher on my own, just because I want to show you something. We'll do negative 2, positive 4, negative 8, positive 16, and so on. So your first term is 1. Your next term is taking the previous term and timesing negative 2. Again, where n is greater than or equal to an integer, you guys can write that down. The explicit formula for that is a sub n equals a sub 1 times the ratio to the power of n minus 1. That is the formula for explicit geometric. First term is 1. The ratio is negative 2 to the power of n minus 1. So you got negative 2 to the power of n minus 1 where n is greater than or equal to 1. Plug in 1. 1 minus 1 is 0. Negative 2 to the power of 0 is 1. Then plug in 2. 2 minus 1 is 1. Negative 2 to the power of 1 is negative 2. So it works. This is your answer. Explicit. This is recursive. Now we're going to just graph it, right? So 1, 2, 3, 4, negative 2, oh sorry, positive 2, 4, 6, 8, sorry, that's the 16 all the way up, so we won't graph it. We'll do negative 2, negative 4, negative 6, negative 8. Now all we have to do is graph it, right? So it's 1 comma 1, 1 comma 1 is around here, 2 comma negative 2 is around here, 3 comma 4, and 4 comma negative 8. And you are done. See how it's bouncing? It's going from positive y-axis to negative y-axis to positive y-axis and negative y-axis. Cool, this is the end of the video. Hopefully it helped. I will, well, see you in class, I guess.